Okay, this video is about how to classify triangles in the coordinate plane. So in order to classify a triangle, the first thing you have to do is know the lengths of all the sides. When you're calculating the measurements of all of the sides, there's two different methods you can use. If a line is horizontal or vertical, like side BC, you can count it. So that's very important. So if the line is horizontal or vertical, you can count. So remember, vertical means up and down, horizontal is left to right. You can count up and down and left and right, however, you can't count diagonally. So if the segment is diagonal, you need to either use the distance formula or Pythagorean theorem. The two methods that we're really going to focus on as far as finding the distance, we're going to make sure that we practice counting and the Pythagorean theorem. The distance formula takes a lot of effort and you have to worry about your negatives. So whenever you do Pythagorean theorem, since it's sides of a triangle, you actually don't have to worry about negatives. So distance formula is a little bit harder when you're proving triangles congruent. So what you're going to do is basically just find the lengths of all the sides. And in our last video, classifying triangles, you should know if all the sides are the same, it's equilateral. If two are the same, it's isosceles. And if none are the same, it's considered scaling. So let's go ahead and start. I'm going to start with the easiest segment. That's segment BC. And you can start wherever you want to. However, I always just pick the easiest one because I want to do the least effort first. So I'm going to title this BC. And BC is a horizontal line, so that means if it's horizontal, I can count it. So what you're going to do is count each individual box. So 1, 2, 3, 4, 5, 6, 7, 8. So the length of BC is 8, and my method was counting. Now remember, this is a coordinate style proof, so you do need to kind of show some of your work. You don't need to show every single step, but I need something so I kind of know what you're doing so I can follow it a little bit easier. All right, our next segment we want to find the length of is AB. That's diagonal. So diagonal methods is either distance formula or Pythagorean theorem, and we want to make sure that we're focusing on Pythagorean theorem. So all you do is build your right triangle off of the segment. That's it. Build your right triangle off of the segment. And then from there you count your boxes, just like we've done previously. So 1, 2, 3, 4, 5. Remember not to count this box. It's not an actual side of the triangle. And then you count the top. 1, 2, 3, 4. So what you end up having, and I'm going to draw it out here, is a triangle that has leg 4 and 5, and you're trying to find the hypotenuse. We're going to be using Pythagorean theorem, and remember Pythagorean theorem is a squared plus b squared equals c squared. It doesn't matter which value you make a or b, as long as the hypotenuse, which is across the 90, is always c. So I'm going to go ahead and do 5 squared plus 4 squared equals c squared. And you can do this straight into your calculator because the variable is isolated. So what you're going to do, 5 squared plus 4 squared. 41. So I get 41 equals c squared. To undo the squared, we're going to square root. You always want to make sure that you test your answer. So the square root of 41 is a decimal. In order to keep our volume or our length exact, I'm just going to keep it under the square root of 41. So this length is the square root of 41. Last thing we're going to do is we're going to find the distance of AC. So I'm going to build my right triangle up and off. Okay. I'm going to go ahead and count. So in counting my boxes, 1, 2, 3, 4, 5. 1, 2, 3, 4. And remember, don't count this box here. It's not actually a part of the triangle. So in this triangle, again, we should notice some similar numbers. We have 4 and 5 again. So that means the length of AC, when I do 5 squared plus 4 squared equals c squared, these two values match. Since they match, my final answer is going to end up being the same. 5 squared plus 4 squared will always be 41, and when you square root it, you'll always get the square root of 41. So you don't have to do any additional math. I'm just going to go ahead and jump to the answer because I know math doesn't change. So I'm going to add square root of 41 here. Next, it's time to just analyze. What do we notice about this problem? We should notice that these two measurements are the same. When we have a triangle where two sides are equal, that's called isosceles. So what you're going to do is write your final statement. Segment AB is congruent to segment AC, but not congruent to segment BC. Therefore, triangle ABC is isosceles. Remember, it's a proof. I don't just want to see your math. I need to see some form of summation, like ending sentence. So let's try to classify the next one, and we're going to move a little bit quicker through this example because it's literally the same. So in this problem, I'm going to pick a measurement. So I'm going to start with AB. That's diagonal, so I'm going to build my right triangle off of it. 1, 2, 3. Don't count this square. 1, 2. Okay. So again, we're going to move just a little bit quicker through this problem because it's the same math. So I'm going to do 3 squared plus 2 squared equals c squared. 3 squared is 9 plus 4 for 13. And when I square root 13, we end up with a decimal. So we're just going to leave it as square root 13. You're going to pick your next side. So I'm going to go ahead and do AC. Build your triangle up and over. I'm going to complete my math for AC in here. Make sure that you're labeling. So I'm going to go ahead and count 1, 2, 3, 4, 5, 6. And this is 2. I'm going to go ahead and not count that square because it's not a part of the triangle. So when you're doing Pythagorean theorem, you only want to count the sides that actually make the triangle. So this triangle has a leg of 6 and 2. So 6 squared plus 2 squared is c squared. 6 squared is 36 plus 4 is 40. Then I square root. The square root of 40 is a decimal. So I'm going to add it over here. Hopefully we're noticing that these sides technically aren't the same yet. So in order for it to be classified as isosceles, like up above, we actually need to get one of these two answers as our final measurement. So all you're going to do again is do Pythagorean theorem. It's the same process. Same process. Nothing changes. You're just finding the length. Notice here that we actually can't count anything, and that's okay. Counting is just a technique that you use if the line is horizontal or vertical. You're not going to use it every time. Sometimes you won't use it at all, like this example. So all you're going to do is count your boxes again. So 1, 2, 3. Don't count this one. 1, 2, 3, 4. Hopefully you recognize a 3 and a 4. That's a 3, 4, 5 triangle. If that's not something that you're recognizing, you can always test it. 3 squared plus 4 squared equals c squared. 9 plus 16 is 25. And when I square root 25, we do end up with a whole number of 5. So remember, this is a special type of triangle. It's called a Pythagorean triple. It's called a 3, 4, 5 triangle. It will always make a right triangle, so I don't actually need to do any math if I recognize that I have a length of 3 and 4. The hypotenuse is always going to be 5. However, if you don't remember that, you can do Pythagorean theorem. It will give you the same exact answer. So let's go ahead and pause and analyze our side lengths. So we have square root of 13, square root of 40, and 5. None of those measurements are the same, so this is going to be classified as scalene. Notice how we have our isosceles triangle statement. Instead of saying anything is congruent, we're just going to use all of these not congruent pieces. So segment AB is not congruent to AC, and that's not congruent to BC. Therefore, triangle ABC is scalene. Remember those 3 dots that form a triangle? That stands for the word therefore. You should be reading your math notation. The more you use it, the easier it is to kind of remember what it means. So this is a full sentence. I'm not describing it in words. I'm using math to describe my sentence. So segment of AB is not congruent to the segment of AC, not congruent to the segment of BC. Therefore, triangle ABC is scalene. Let the notation that you already know kind of speak for itself. Use the notation you're learning. All right, our last type of triangle, is triangle ABC a right triangle? The way that you're going to show if you have a right triangle is you should have one 90-degree angle. So one angle has to be 90. The way you prove 90-degree angles in the coordinate plane is using slope. You have to have perpendicular lines. Remember, perpendicular lines are opposite reciprocals, meaning the fraction must flip and the sign must change. So in order to prove if something is a right triangle, all you do is you find the slopes of all the sides and compare. So you actually don't change any of the slopes. I know we're used to, okay, make it perpendicular, so we'll flip it and change the sign. In this case, we're just finding the slopes and then we're comparing them ourselves, looking for a perpendicular slope pair. We're not actually changing it. So let's go ahead and start with AB. Remember, slope is change in y over change in x. So I'm going to count up 1, 2, and to the right 1, 2, 3, 2 over 3. Next I'm going to do AC, change in y over change in x. And remember, one good thing we're doing is we're writing this out to kind of follow our math, but then we're putting x on top. Remember, y on top. So I'm going to always start to where I'm counting in a y direction first. So up, 1, 2, 3. Left, 1, 2. So left is a negative direction. And we got our last one, segment BC. Remember, change in y over change in x. I'm going to start at B, so I'm always traveling in a y direction first. So down 2. Negative, oh, not down 2, down 1. Sorry about that. Do I have mine out? Good question. Nope. Okay, so we're just going to cross this out. So down 1, down 1, and then right 1, 2, 3, 4, 5. Negative 1 over 5. The next thing you're going to do is just analyze your slopes. Do you see any opposite reciprocals? Looking at this, we're looking for perpendicular because perpendicular makes 90 degrees, and 90 degrees means it's a right triangle. So I have 2 over 3, 3 over negative 2, and negative 1 over 5. Well, the negative 1 over 5 obviously doesn't match anything. So I want to focus on the 2/3 and the negative 3 over 2. When you're looking at those slopes, 2 over 3 flipped and became 3 over 2. The first fraction was positive, so that means the next fraction has to be negative. So these are our perpendicular slopes. So our final sentence is going to read, segment AB is perpendicular to segment AC. Therefore, triangle ABC is a right triangle. All you have to do is perpendicular slopes. Notice how we didn't manipulate those slopes. I didn't make them perpendicular. I found the slopes of each of them and compared. So to recap, remember, if you are finding whether or not it is isosceles or scalene, like the first two, you do Pythagorean theorem or count. Distance formula is not recommended because you deal with negatives, and nobody likes to deal with negatives. So if you're classifying by sides, you have to do Pythagorean theorem or count. On the bottom, if you're classifying by right triangle, you have to find the slopes of all the sides and look for the perpendicular ones.